All right, folks, we're moving on to section 10.4, which is inscribed angles. This is a pretty lengthy set of notes, so we're going to have to cut it in half. So inscribed means that vertices are on the circle, and inscribed angles are angles with their vertices on the circle. So we're going to want to pay attention to that, and then I have a review of what we learned before as we go through these notes. So taking a look at right here, arc ADC, so ADC goes right here, is the arc intercepted by an angle. So you have angle ABC. So that is on the circle. So that's called an inscribed angle. So be careful when you go through those today. Vertex B is on the circle. AB and BC are the chords of the circle. So these are all things to pay attention to as you go through examples today. And now once we define that term, we have an inscribed angle. So this angle is on the circle. And what it does here is it creates an angle at 1 and an arc right here. So the angle is going to be equal to half of the arc. The angle is going to be equal to half the arc. So again, take a look here. We have an inscribed angle. Yep, right here. That's on the circle. The angle is 30. The arc is 60. Angle is 30. Arc is 60. So you can see you can go in reverse if you need to. Now this is a review from section 10.2 when these angles were central angles. A central angle, again, is when it goes through the center of the circle and intercepts an arc right here. So we have to be careful of that. Be careful of that when we go through these today to make sure, because that angle is equal to the arc. The arc equals the angle. That's only if it is a central angle, if it goes through the center of the circle. So again, be very conscious of that as we're going to go through here. In this example here, it says find the measure of angle x. And then I also added in the find the measure of an arc. So here's angle x right here. Is it an intercepted angle, inscribed angle? Yup. So you look at the across from that, it's 86. You take half of that. Final answer is 43. So to find this arc right here, you have the angle opposite. You are now going to double that. So times that by 2. And your final answer in the case of the arc is 104. So again, something to pay attention to, you know, as you're going through to get through that equation. Same concept here. They want you to find the measure of angle C. Here's angle C. Is it an inscribed angle? Yep, it's on the vertices on the circle. You take 94, you take half of that, you get 47. Now they want you to find this arc right here. The angle opposite's 48. You double that, so times that by 2. So that will give you 96. So that I know that option's not in there because I just added that in, just to work in opposite of both directions. Now read through this theorem here. 2 inscribed angles of a circle intercept the same arc. So you notice this green arc, the blue angles intercept that here, and then the red go here, and it's going to equal. If this arc was 70, then they both of those angles would be half of that, or 35, because they intercept the same arc. So taking a look here, going back to our example with 30 and 60. So this angle's 30, intercepts this arc. So when you say intercept, follow the chords. So that intercepts that arc. Same thing over here. What is the measure of this angle? Well, follow the chords. It intercepts the same arc, which is 60. So you take half of that and you get 30. Just got to kind of follow those to see where you're at. So taking a look at this one here, again, here's an angle, here's an angle. They both intercept, follow the chords, the same arc. Set those two equal to each other here. Solve, you get that x is 5. But then it asks you to find the measure of angle r. So they want you to find the measure of angle r. That one's right here. So 12 times 5 minus the 13. 12 times 5 minus the 13, that gives you 47 degrees. So if they're looking for the angle, that's where we're at with that. Next, try the same type of an example here. Intercepts the same arc, so set them equal to each other. 8x plus 9. Oh, this board is way off today, folks. Equals 10x minus 1. Solve that, we get 2x. Oh, equals 10. And x, oh man, x equals 5. Oh, this board is off. This is going to be a struggle. So x is going to be 5 right there. And then you're going to want to plug that in to find, it asks you to find the measure. Let's see what I can do here. Find the measure of angle L or I. That's right. Board's way off down here. So you're going to go 8 times 5 plus the 9 final answer is going to be D, 49. Sorry for the board issues today. All right, so taking a look at this one, I would start by plugging in the measures of all the arcs they give you. So this is 140. They give you that BC, the arc is 100. They give you that AD, and these two here are equal. So again, we're talking 360. All the arcs are 360, so we're going to go 360 minus 140 minus 100. Okay, so we're going to subtract those two arcs, and that's going to give us 120. And then you have two equal parts, so you divide that by 2. So that's where we're going to get each arc is going to be 60. So by finding all those arcs, we now are going to be able to find those angles. So here's angle 1. What arc does it intercept? So follow this, that's here. Follow this is here. So that's 60. You want to take half of 60. Okay, so angle 1 equals half of 60, so that is 30. Same thing here. Let's follow angle 2. Follow that. You're going to get 60, so angle 2, half of that is going to give you 30. Next, we want to find angle 3. Here's angle 3. Flow with that. Half of 100. Half of 100 is 50. Let's look at angle 4. Angle 4 is here. Go over here. You're going to go half of 140. That is 70. And then now angle 5. Here's angle 5 here. Angle 5 intercepts this arc right here. Half of 100 is 50. So that gives you an idea of what all those are going to look like. Next one here, we may be able to get through all these notes. We'll see an inscribed angle is intercepted by a diameter semicircle. So this is a diameter right here. That's going to make this a 90-degree angle because it's half of 180. This is 180. It's a semicircle. Half of that is 90. Same concept here. Same idea here. And again, they're showing you how to solve this. Again, if I knew that this is 90, then I'm going to set this plus this equal to 90, and I'm not going to go through this entire setup, but it's the same idea. You get that x is 10, but then they ask you ultimately for the measure of angle B. So that is 8 times 10 minus 4. So 80 minus 4, that is 76. That would be your final answer for the measure of angle B. This one they want the measure of angle D. So again, this is a semicircle. This is 90 degrees. I'm going to go 2x plus 6 plus 8x plus 4. I'm going to set that equal to 90. Because again, it's the same as if you were to subtract it over. So this is 10x plus 10 equals 90. Subtract over the 10. 10x equals 80. Divide, and x equals 8. So x is 8. They want you to find ultimately angle D. Here is angle D right here. So that is the 2 times 8 plus 6. Final answer is going to be C. Final answer is going to be C. Let's see here. I'm going to pause right there.